All right, y'all, this is problem 4 from the 2018 exam. So let's go ahead and look at it. The height of a tree given at time t is given by a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given above. The first thing we want to do is use the data in the table to estimate h prime at 6. Using correct units, interpret the meaning of h prime of 6. All right, so let's look at this. So for A, we would like h prime at 6, and we are approximating that. Now remember, we want to pick, since we're given a data table, these are the only snapshots we have. We're going to have to leverage 5 and 7 because 6 is in between them. So we're going to do h of 7 minus h of 5 divided by 7 minus 5. So I'm going to get 11 minus 6 divided by 2, which is 5 over 2. Now, it wanted us to interpret this as well using correct units, right? Yep. So what this means, h prime of 6 is the rate at which the height of the tree is changing in meters per year. At time t equals 6 years. All right, so for grading purposes, you got a point for the estimation, and then you got a point for the interpretation with the units. So you needed to talk about the rate and explain the units in the context of the problem. That's what they were looking for to give you that point. Now for B, let's look at B. So for B, explain why there must be at least one time from 2 to 10 such that h prime equals 2. All right, so let's look at this. All right, so if we look at our data, the only ones that kind of lend themselves to getting a slope of 2 are 2 and 6, and then this gap of 2. So I'm going to check on 5 and 3 and see what goes on. So h of 5 minus h of 3 divided by 5 minus 3 is equal to 6 minus 2 divided by 2, which is 2. Okay, so you got a point for that. And then you also need to conclude why that's the case. So you're going to basically say, since h is differentiable, and continuous on the interval from 3 to 5 by the MVT, there exists a value C on the open interval such that h prime at C equals 2. So that is the second point. Now, I would argue on this one that unless you look at it and immediately think, oh, mean value theorem, this might be a harder 2 points to get when I can tell that the one below it is a Riemann sum, which most of you are good at. I will say this is a trapezoidal sum, but most of you are good at the Riemann sum, so if you wanted to skip B and move on to C when you are focusing on your 4 to 5 easy points, that might be strategic here. So let's look at C. Use a trapezoidal sum with 4 subintervals indicated by the data table to approximate the average height of the tree over the interval from 2 to 10. So look, they give us the 4 subintervals. So let's look here. It wants us to find the average height, right? And so if we look, we're going from 2 to 10. So we want the average height here is going to be 1 over 10 minus 2 times the integral from 2 to 10 of h of t dt. Now we want to use trapezoid to approximate this, so it's going to be 1/8 from the fraction right here. And then we're going to have to do our trapezoid method. So trapezoid method says you do the left plus the right divided by 2 times the width of that piece. So we would do 1.5 plus 2 divided by 2 times 1 plus 2 plus 6 divided by 2 times 2, right? I'm getting all of these numbers from that data table. Then I get 6 plus 11 divided by 2 times 2 plus 11 plus 15, I'm running out of room, times 2. And then remember, you don't have to simplify that. You got a point for the trapezoidal sum and a point for the approximation. So I guess 2 points for this. So that's pretty generous. That gets you up to that 4 nice pretty points that you wanted. Okay. Now let's look at D for those final points. So for D, the height of the tree in meters can also be modeled by a function. So it gives us a new function, right? So make sure you're using that appropriately, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of, so this is going to be important later too, right? According to this model, at what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall. So essentially what they're asking us to do is they want us to find, now keep in mind that g of x equals 50 when x equals 1, right? They told us that in the problem stem. So we would like to find d dt of g of x, right? And so what that means is I'm going to need to take the derivative of this function right here. Now, here I'm going to have to use 2 things. I'm going to have to use quotient rule because I have a quotient of 2 different things, and I'm going to have to use chain rule because I'm taking the derivative with respect to t. So I want to be extra careful about that whole situation. Okay. So here I am going to do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. But I took the derivative of x, so I need to multiply by the derivative of x. Okay, you got 2 points for this. You got a point for this, and then you got a point for remembering the chain rule. If you forgot this friend right here, the most points you could get on this was 1 point, and it was for this part of the answer, just so we're all on the same page. Now, to get the final answer, we want to plug in our values. So we want this at 1, right? So here, we want it at x equals 1. So dt of g of x at x equals 1 would be equal to 100 over 1 plus 1 squared. Now, all that I did was I simplified this, y'all. So, like, this is the simplified version of this. You could have plugged it in as is. I went ahead and simplified it to save a little room. And then my dx dt was 0.03. And that's going to be equal to 3/4. And then that's the third point. So if we're like counting up easy points, let's go back through this because I think this one's a little tricky. I think A, not too bad. All of you can do A. B, if you remember mean value theorem, not too bad. However, I would argue that if you don't, off the top of your head, C is a much easier place to earn 2 more points. And then all of you are capable of taking a derivative with quotient rule. So at the very least, you're all capable of getting this point. And then if you remembered the dx dt, it wasn't hard to get to this third point. So I think this was a really fair problem. So hopefully this video helped. I'll see y'all on Monday.